So just a reminder, the word algebraic means basically you're given an equation. We've already looked at graphs of slant asymptotes. We found out what they were. Remember, it has an equation of a line in slope-intercept form. So for example, y equals 2x plus 4 would be a slant asymptote. And you can do that just by looking at the graph, which we'll see in a second. But algebraically means you're given an equation, you're given a formula, and you have to figure out what the slant asymptote is. Again, like I told you, basically if you can divide polynomials, then you can easily find the slant asymptote. But here's what a slant looks like, okay? Like I said, if you're given the graph already, you basically just, find the y-intercept. So this would be 0, and then the slope is 2, because you go up 1 and over 2 to get to the next point. So it would be 2x plus 0, which is just 2x. That'd be your slant. So it's easy to find it graphically. You just find the equation for the line. Okay, next slide is really important, and basically it's going to tell us when it has a slant asymptote. Not all formulas have slant asymptotes. Not all rational functions have slants, only certain ones. This has to be true in order for it to have a slant asymptote. Whenever the highest power in the numerator is 1 more, and it has to be 1 more, it can't be 2 more or 3 more. Whenever it's 1 more than the highest power in the denominator, there is a slant asymptote, okay? And if not, then there is none. We're going to look at some examples in a second, and I will keep it there so you can copy it. Let's take a look at some examples of equations that have slants. So if we look at this first equation, the highest power is 5 on the top, highest power on the bottom is 4. That means that the highest power on top is one more bigger than on the bottom, so it will have a slant. Same thing for this one. The highest power, it's not always the first one, right? The highest power on top is 2. On the bottom, even though it doesn't say 1, we know that's x to the first. So that would also be considered 1 more. And in this case, again, we would know it has a slant asymptote. I'll give you a second to copy that. But on the next page, we're going to look at 2 examples where they do not have slants. Okay. So next, we're going to look at 2 examples of equations or formulas that don't. So, we have y equals 2x to the 7th over 4 minus 3x to the 4th. Well, 7 is bigger than 4, but it's not 1 more. It's got to be exactly 1 more. So this would not have a slant asymptote. Here, almost looks like it would work, but the power is bigger on the bottom. So it wouldn't have a slant. Actually, it would have a horizontal, right, at y equals 0, because the power is bigger on the bottom. So not all of them have slants. Even on your worksheet, there are a couple that will not have a slant. You can identify it and just say no slant asymptote. Okay, let's go ahead and do example 1. I need to delete some of that notation there. Okay, we have f of x equals 3x squared minus 1 over 2x plus 3. Is the highest power on top 1 more than the bottom? Yes, there's technically a 1 there. Okay, so that means we can find it. And I've already alluded to how we're going to do this, but basically you're just going to do long division. All right, division problem now. This is our numerator, this is our denominator, so it's going to go to the left of the fraction bar. Basically, it's pretty much one step, okay? You're going to do long division, and you're not even going to worry about the remainder. In other words, that number that shows up at the bottom when you do the long division, the only thing you have to worry about is the top of that division bar. That will be your slant asymptote. Okay, so there is a missing power in the top, so we need to put a 0x there, like that. And so here's our denominator, here's the numerator. First thing we're going to do, take the first term in the numerator, divide by the first term in the denominator. So this one you do get a fraction because, yes, x squared over x is x, but 3 over 2, you could put 1.5, it's the same thing, but it is a fraction. Now, I don't think you're going to get any fractions on your worksheet, fortunately. Just ended up being this way. Yes.
So now we're not using the remainder, but wouldn't that be a positive 23 over 4?
Hmm. 27. Yes, you're right. That was eagle eyes because it's minus minus. You're right. I would have never noticed that. We'll get to that in a second, but he's right. It's plus. Because it'd be minus 4 over 4 plus. Yeah, you're right. Okay. So 3x squared over 2x is 3 over 2x. And you take that number and you multiply back, okay? Again, you know, if you multiply this by this, you should get the same thing you started with because you're just undoing what you did. Then take 3 over 2x multiplied by 3. That gives you 9 over 2x. That's the reason why we filled in this missing power. When we subtract what's in the parentheses, we get minus 9 over 2x because it's 0 minus that, and then the minus 1 drops down. Okay, so now we take the first term here and divide by that. So it's negative 9 over 2x divided by 2x. Well, first of all, the x's are going to cancel. Then we have negative 9 over 2 divided by 2. That's the same thing as negative 9 over 2 times 1/2. So you get negative 9 over 4. I'll show that real quick. So actually, I'll do it on a different page. You have negative 9 over 2 divided by 2, like that. It's the same thing as negative 9 over 2 times 1 over 2, which is negative 9 over 4. So that's where that comes from. Then you take that number, you re-multiply back. Of course, you get the same thing for below that. Negative 9 over 4 times 2 is negative 9 over 2x. And then negative 9 over 4 times 3 is negative 27 over 4. You take the parentheses and subtract, but it won't matter because you get a number down here. It really doesn't even matter what that number is. It's your remainder. You don't use the remainder when you figure out the slant asymptote. You only worry about what you get up here. So this is your slant. Whatever you get above the fraction bar is your slant asymptote. And, you know, just for a final step, you can just write y equals that, or or f of x equals what you get on the top. And you don't have to convert it to a decimal, but that's what it would be. 9 over 4 is a decimal. So you can just put this, or like I said, you can just put y equals, and that will be your slant asymptote. Let's do one more example. Actually, I want to show you guys what this would look like. I graphed this, and here's the graph of the function 3x squared minus 1 over 2x plus 3. As you can see, it is formed by this asymptote, and we found an equation for this dotted line. This was the equation we found. Y equals 3 over 2x minus 9/4, which is 2.25. If you look at the graph, you can see it intersects at negative 2.25, has a slope of plus 3 over 2. But again, not all rational functions have slant asymptotes. Okay, one more example. We have h of x equals 2x cubed minus 3x plus 1 over 1 minus 2x squared. So this one has two missing powers. The top has a missing power, has no x squared. The bottom has a missing power. It has no 0x. And furthermore, the bottom is not in order from biggest to smallest power. So when we set up the division problem, we want to make sure it's in order too. So the negative 2x squared comes first. Step one is going to be the same for this problem. We need to set this up as a division problem. Again, make sure that we order the powers on the bottom and filling that missing power. Same thing for the top. So we're going to put the 2x squared first, negative 2x squared first on the bottom because there's a negative there. And then there is no x term, so I'm going to put plus 0x. And we're going to put the plus 1 after that in descending powers. In the numerator, we had a missing 0x squared term, so we need to fill that in. So next, we have 2x cubed divided by negative 2x squared. That's negative x. okay? Because 2 over negative 2 is negative 1. Now, when we re-multiply this by every term here, we get, first of all, we get negative 2x cubed, obviously. No, we should get positive 2x cubed. I messed that up too. But we're subtracting it, so it goes away anyways. And then we have negative x times 0x, that's just negative 0x squared. Negative x times 1 is negative x. Now, when we put this around parentheses and subtract it, it becomes plus x. So negative 3 plus x is negative 2x. But remember, when this power down here is smaller, you stop, okay? This is negative 2x to the first. This is negative 2x squared. So we don't have to divide anymore. So this is our slant asymptote. All right, it's actually just going to be y equals negative x. Okay, taking a look at the graph. Again, here's the graph of the function, this function right here. Okay, so the blue line is that function, but the red line is the slant asymptote, y equals or h equals negative x. So it has a slope down 1 over 1. It has a y-intercept of 0. What I want you to notice is, yes, it does form the shape of the graph, truly, but the graph goes through it. We talked about that when we did the first worksheet on asymptotes. Can a graph cross through a slant? Yes, it can. It can't cross through a vertical, but it can cross through a slant. All right, any other questions about this before I give you the worksheet? I think there's just 8 problems on there, so.